Graphing inequalities. We've done quite a bit of work with graphing equations, right? Linear equations. And these will most likely all be linear inequalities, right? Just the x with a one exponent. Or hopefully it'll be in mx plus b form, right? Now, do you know how when we graph just a line and there's one of the points that doesn't get included in it?
Yeah.
And you use what kind of circle? Okay, and any point that is included, what kind of circle? Okay, so when something is less than or greater than like the entire line itself, like with an inequality, you can't really use open and closed circles, right? Have you ever graphed inequalities earlier in your career?
No.
Where you might graph a line and then shade one side or the other?
Yeah.
Oh, so there we go. Okay. Huh? Well, these guys do, right? So if you have, y is greater than a bunch of stuff and you plot the line, and since it's greater than, you shade above the line, right? If you have y is less than stuff and you graph the line, you shade which way? Below the line, yeah? What if it's, so if it's greater than or equal to, you remember, you use a solid line, right? And if it's like less than or greater than without the equal to, what kind of line did you draw? Dotted line, yeah, dashed line, right, okay. So you have kind of seen this before, right? Let's see here. So we have this inequality, y is greater than x plus 3. Is that linear? Is that in mx plus b form? Okay. So let's see if these points are solutions, right? We've done a bunch of those in the last section. So 2, 7. So 7 greater than 2 plus 3. It sure is, right? Everybody agree it's greater than 5?
Yeah.
Let's try 0, 1. Is 1 greater than 0 plus 3? It is not. 1 is not greater than 3. So no. And over here is 4 greater than 1 plus 3. 4 is not greater than, well, itself, right? So no. Okay? So one of those points was a solution. The other two were not. So let's go down here. So this is y greater than x plus 3, right? And so we're going to graph this thing. So let me ask you a question. If I were to graph the line y equals x plus 3, given that that's greater than, would any of the points that make the actual line be a solution to it? It's greater than without the greater than or equal to. Well, okay, let's go to this here. So we're going to graph this thing here, but they're going to start out having you graph the actual line part of it as if it was equal, right? Okay? When I graph that line, you already know we're going to shade above or below it, right? But points right on this line, will the points that are actually on this line here be a solution to that?
No.
No, why not?
Because it's equal to.
There's no equal to up here, and this is where we would make what kind of line? Dashed, right? Because there's no equal to. It's analogous to open circle, right? It's there, but not included, yeah? Okay? So let's graph this line, y equals x plus 3. Well, what does it say? Oh, we just talked about, why are points at y on the line not part of the solution? Okay? Well, points on the line are where they're equal, right? Let's just say points on the line are where they are equal. What's a good way to say it? To the line. But what's the problem with that? If y is actually greater than x plus 3, let's put it that way. If y, as they have it up there, is actually greater than x plus 3, what can we say? Yeah, right, well, it doesn't include any equal values, right? It does not include any equal values, the ones that would be equal and otherwise true, right? That makes sense? That's a long-winded way to say I think we can kind of get intuitively, right? All right, well, let's go ahead and plot this. Let's plot this here. This y equals x plus 3. What is the slope of it? No, the slope is never the letter. What's in front of it?
1.
1 over 1, right? And what's the y-intercept? 3, yeah? So you guys should know how to do this by now. So we go on the y-axis to 3. Which way do we proceed from there? Up 1 over 1. Or up 1, right 1, up 1, right 1, right? Like that? Basically from there, it's just going diagonal. You see the pattern, yeah? Like that? All right, let's get our straight edges out. Everyone has a straight edge, right? If not, you should grab one. And your line should look like this. Right?
Are we gonna have to label them?
Label what?
Label them.
Yeah, well, if there's more than one.
There's gonna be
Correct.
more than one.
Yes, sir?
About 3 per x.
Points. Those aren't lines. Right, they're not graphs, right? All right, so really this is supposed to be y greater than stuff, right? And like, also, I would say, if you have one of these linear inequalities that's not an mx plus b form, right? You always want to get it so it leads with y either greater than or less than other things, okay? In other words, mx plus b form. Because that'll tell you, because the y measures up and down, right? Right? Okay. So if y is greater than anything on the, oh, by the way, we got the wrong kind of line there. We'll fix that in a minute. If y is greater than anything above this line, then which way, or anything on the line, which way do we shade, above or below? It says greater than, so what would be your guess? Above, right? So we shade above. And it's a good idea to put a giant S in there for solution, yeah. I'm going to fix my line, and you can do it like take your eraser and just make dashes in there. So if I change that to like that, there we go, that was easy. So it should be a dotted or dashed line, yeah? Why is it dashed and not solid? Because the inequality doesn't have an equal to in it. Right, let's take a couple of these. So it said plot the 3 points. So let's plot 2, 7. We said that was a solution, right?
Yeah.
So go over 1, 2, 1, 2, 3, 4, 5, 6, 7. Whoopsie daisy. Where is it? 2, 1, 2, 3, 4, 5, 6, 7. Right there, right? So here's my 2, 7. That lies in the shaded region, right? The other point there was 0, 1. Well, obviously, that's not even near the line or in the shaded region, right? So it's not going to be a solution. And what was that last point? Here's the one that, so 1, 4. So go over 1, 1, 2, 3, 4. It's that point right there. Do you see how that point falls right on the line? And that line is dashed for that reason, because it will not include that or any other point. Remember up here? It's because we said that 4 is not greater than itself, right? Okay, so you understand the dotted line thing, yeah? It's analogous to just the open circle, right, versus closed circle, dotted line versus solid line. Okay? So if there was an equal to sign, if it was y greater than or equal to x plus 3, what kind of line would we have used? Solid line. Because then everything on the line would make it true, right? You get the idea now? Okay? Choose the fourth point. Yeah, all right, we get the idea. We don't have to do part D, right? Do we? Pick whatever point out. If you want to do it, you can do it. All right, party point 10, 12 cannot be drawn on the graph above, so it's difficult. I don't know how difficult it would be.
What is the 12?
10, 12.
10 plus 3.
Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. Well, I don't know. It might be kind of close there. So how are we going to find out if 10, 12?
Wait, no, don't you do the, yeah, you just call it
Yeah, it doesn't fit on the graph. If I estimate it, boy, it seems like it's going to be maybe right on the line. I don't know, but we'll plug it in. So y greater than x plus c. So is 12 greater than 10 plus 3?
No.
12 is not greater than 13. So no, it does not lie in the shaded region. Okay. So far, so good? Anybody stop me if you have a question? Yes.
They were doing 4.10
Yes, and 11. Good thing it's easy, right?
Yeah, that's easy.
I mean, I don't really want to do this one right now.
Okay. There's challenges. Let's look at the worst case. And boy, they are really histrionic in the writers. It's drama.
Say drama.
It's drama. So now we have an exercise 2, this thing. 3x minus 2y greater than or equal to 2. I'm not going to bother with part A. I don't like when they say rearrange the left-hand side. What they really mean is we want to be able to find m and b, right? Can anybody tell me what the slope of this line is? What's the m? Oh, no, you didn't just say that. No, you didn't just say
No,
that.
you can't.
Why can we not determine the m and the b right now? It's not in y equals mx plus b form, right? So we have to do that. We have to get this in y equals mx plus b form. So I will write want y equals mx plus b form. And that's what we're going to do in part B. So let's write down the inequality. 3x minus 2y greater than or equal to 2. So to get this in that form, somebody other than Emily, tell us what we need to solve this for. What? Y, right? Because there's the form of y equals. Well, it's going to be greater than or equal to, right? So what do we do first to start getting this y by itself? We've done this a million times, right? So let's subtract 3x from both sides. That goes away. What's that leave us with here on the left-hand side? Negative 2y greater than or equal to. Right, I'll just kind of rearrange it so it starts to look like mx plus b, right? What do I do now?
-2.
Divide by negative 2 every term, yeah? That gives us y. Speak, go ahead. Oh, it was what? Why did you switch to less than or equal to? Because you just divide it by a negative, right? Y is less than or equal to what?
0.5.
How about 3/2 x? Go ahead. Go ahead, what? Minus 1. So there is something where we can identify m and b, right? What kind of line will we graph for this, by the way? Solid or dashed? Dashed? I hear dash, solid.
I have
What?
no idea.
Yes, you do.
What? No.
It's either gas or equality.
It's dash because there's no equal.
What's that?
It's an equal.
Yeah,
So it's not.
I don't.
solid line. So this will be a solid line. See that? Less than or equal to? Right? That means we need a solid line. Yeah?
So what do you say below then?
Okay. So it's y less than stuff, and below indicates less than. Right? So yes. So let's plot our y-intercept at what? -1, and which way do we proceed from there?
Up 3. Right 2.
Up 3, right 2. Right? Correct, I should say? And you take your straight edge. You should get one of those. Right in front of you. Okay. That. We understand why it's a solid line, right?
Yeah.
Because it's a less than or equal to.
If it's equal to,
Or like has an equal sign, it's gonna be solid.
Yeah. Because that means everything on the line is included, right? So which way are we shading this, kids?
That's why.
down, the bottom
Whoa.
side. the
It's
bottom
less
side.
than, so we shade below. You don't have to get like crazy about it.
What's the shading for?
That means this is, every point on this side where the shading is a solution to that.
Oh.
Any point you pick here, or on the line, so on the line or less than the line, hey, look, 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 look. So less than
Oh, that's
or on the
not-
line, less than or on the line,
If it's not, it means it.
it would just be less than.
If it's on the line,
If this was just less than, we'd have a dash line. Okay?
because it wouldn't be able to be on the line.
Correct. Well,
Because it's-
points are on the line, but they wouldn't be a solution.
It's like the
Yeah.
line isn't there.
It'd be like getting 4 less than 4. Not true, right? Okay? And again, and that's like the open circle, right? Versus closed circle, okay? So pick a point in the shaded region. I don't know. How about we pick like
Negative
3-1?
three,
I already got you. 3-1. 3-1. See, verify. Now go back to the original equation, by the way. Put 3-1 up here in the original equation. Inequality. I misspoke. Okay? So it'll be what? 3. We're going to do 3. Oh, man. 1. So that will be 3 times 3 is 3 times 3 minus 2 times 1 greater than or equal to 2. Is 9 minus 2 greater than or equal to 2. Is 7 greater than or equal to 2? Yes. And you see how algebraically made the inequality true? And 3-1 graphically falls in the shaded region, the solution set. Raise your hand if you get the idea here, what we're doing. Okay. Raise your hand if you understand which way to shade, above or below.
This is easy, I understand it.
You don't understand which way to shade?
So I really did not take time for me to understand.
Do you see the line that we graphed? And do you see that y here is less than stuff? When you're measuring up on the y-axis, which direction is less than things? Up or down? Down. And then the other one,
Oh yeah.
this one here, was greater than. So which direction is greater than? Up, above,
What's on the line?
right? Okay. All right? Okay, so now in exercise 3, you got some horizontal vertical lines, right? You remember those, yeah? What's the first question you asked? for the horizontal and vertical line? What axis
Is it going?
does it
to the
cut through?
axis?
Oh, the line.
And where does it cut through it at, right?
Oh, yeah.
So this would be at 4.
So now, this is gonna be the inequality x is less than 4. So what kind of line will we graph?
Solid
or dashed?
A dash.
Dashed, is what I'm getting at. What axis does this cut through?
Oh, X.
It cuts through the x-axis, where?
At 4.
At 4. 1, 2, 3, 4. So we're gonna use what kind of line, everybody?
Got it. Or dash.
Dash line. 1,
It just
2,
doesn't really
what doesn't?
line.
We'll try to make it look like one.
It's kind of hard. Math.
I'm just gonna do it on the side so it doesn't like blend into the line.
Yeah, that's fine, because like your pencils are like the same color as the, that's a valid thing to do, yeah. All right, now, which way are we gonna shade?
So this.
Well, now we're looking at like measured by the x. This is less than, right?
Go to the
Yeah.
left.
Isn't stuff to the left less than? Stuff to the right would be greater than? So we shade out this way.
That was easy.
Yeah,
Wait, what's the S for?
solution set. They like you to do that on the Regents exam.
Okay.
Wait, so
That makes
Shade
sense. I will do
and
that.
put an S in there.
how can we go from like really, really hard stuff to
I
like,
know,
so
to like easy stuff. and then
Because this will build up to something else that's more fun. You guys use the word hard, I say fun. All right, let's try part B. What is this in your own word stuff?
that
No.
I saw
Whatever.
I saw the
line
one
goes
YouTube
through
Okay.
the guy.
So just, I will note this. That means you're going to have a dashed line. And when we get over here,
salad.
Solid line.
everybody agree that that will need to be a solid line.
I thought equal to was
No, the dashed line means the stuff on the line is not actually in the solution. It's like a border, it's like the shading goes, it's like the open circle. It goes up to it, but not including. So the dashed line is like all the shading goes up to it, but not including the stuff on the line. Pick a point on this line, an x value of 4.
4.
Hannah? Would you agree that the coordinates 4, 0 is on that line? Okay, so will that make this true? Is 4 less than 4?
No.
That's why it's dotted, right? Because it's a boundary, but, right, for the shading, but they're not actually included. It's like the open circle. It's like an endpoint for the line that's not actually included. Okay?
That is a very important.
All right, now, y greater than or equal to -2. What axis are we cutting through?
Y.
Where?
-2.
What kind of line?
Horizontal.
Horizontal, yes.
The size is
Solid.
bigger than, so it's
Right. Okay, down there.
How do you know it's horizontal?
Well,
Don't mind
if
that.
it's gonna cut through the y-axis, yeah.
Yeah,
Right.
I was.
So I think-
I was like,
I would say this, Hannah, if someone asks you if it's horizontal or vertical, first ask, what axis is it cutting through? Then picture it, oh, that's horizontal.
Why did they-
Horizon.
Okay,
Horizon is the X.
so solid line,
Horizon.
right? A
Like
little off
your
there, but,
motions like this.
What are you talking about?
It just made me think of that, because my mom used to get so
I don't wanna do it.
seasick, like, she's-
okay, well, agree it's a solid line. Which way are we gonna shade, guys?
she watched them go.
Why above? Because we need stuff greater than this stuff on the line, or equal to. Solution set. Got the idea?
Yeah.
Okay, I believe there's one Regents question. the one just like this on your test. You might want to make sure you don't forget it. Read this over.
So we get that,
So what does Miranda have? What does she receive?
movie gift
For how much?
$100.
To a local theater. I guess this theater has two types of shows, right? A matinee, you know what that is, yeah?
That's like a, I
It's
don't
like
know.
the afternoon show. You can go at 12, 1 o'clock, afternoon, you know.
It's usually cheaper.
And then the evening, matinees are less expensive.
Matinee.
Matinee.
Matinee,
It looks
that's
French.
the afternoon showing in a movie theater, early afternoon, you know.
Me and my dad used to just go to matinees.
Okay. So how much do the matinee tickets cost at this theater? And the evening tickets? $12.50 each. So you have $100, you could buy some combination of both of those tickets, right?
Yeah.
You could buy a whole bunch of one and none of the other, or vice versa, or kind of split them up. Yeah, well, what's the question, Tegan?
When does afternoon?
So you could buy more than one of each ticket, yes?
Yeah.
And how would you, let's say you bought 5 matinee tickets and something, how would you get the total cost of matinee tickets? What, no, just, if you were to buy 5 matinee tickets, how would you get the total cost of matinee tickets? 5 times 750, or 750 times 5, right? If you were to buy 4 evening tickets, how would you get the total cost? 1250 times 4 of them, right? Okay? So, whatever combinations, 5 or 4, whatever it is that you buy of each one of them, what's the most you can spend? $100, okay? So could we write an inequality here? Yeah? Okay. What do you think it might be? It says, and they say they want X to be the number of matinee tickets, right? So the matinee tickets, the number will be X. That's what they said they want.
Wait, y equals
Yeah, hold on. And the evening tickets, they said they want to be Y. So what would be the inequality here, guys?
y is less than or equal to mx plus b.
Well, wait a minute. If X is the number of matinee tickets, how do you get the total cost of matinee tickets? 7.50 what? Times X, the number of them, right? Yeah. No, yeah, I got the, where it's stuff. What's you got? I got it. $7.50 times the number of them X, so 750X, right? And now presumably you're also going to buy evening tickets, right? So you'd have to add to that what? 1250Y. Yeah? Everybody understand that? 750X, right? You understand that's the price of the matinee tickets times the number that you buy. And we have to add to that what, guys?
1250. What?
1250 times Y, the number of evening tickets you buy. How much money do you have total? So should this equal 100? Be greater than 100?
Less than or equal.
It's got to be less than or equal to 100. You ever understand how to write that? Because you'll have to do that on the test when you see a problem like this. It's not tough though, right? If one of them is 750 each, it's just 750 times however many you buy, X. And the other one's 1250 apiece, so 1250 times however many of those you buy, Y. And you have no more than $100 to spend, so less than or equal to 100. All right, so I want to graph this, yeah?
We gotta put it into MX plus B.
Yeah, and later on, there's a different way to do that. It's actually easier than doing that, but for now, we're going to do that. What kind of line will it be? Solid or dashed?
Dashed.
Solid.
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 Sorry.
Okay, so what we want to do then is solve this for what to get it in y equals mx plus b?
Uh-huh.
Y. Okay, everybody do that right now.
I still don't understand how that would be solid though.
Equal.
Yeah.
Whenever you see an equal to sign, you're going to have a solid line.
Just sink that line underneath it into the solid line.
Yeah.
Okay, if that
the
helps,
line,
yeah.
the solid line underneath the equal Then 8-3 over 5.
So I'm gonna subtract 7.50x from both sides, right? Because I want the y to remain over here. For the love of all that's holy, these are not like terms.
100 minus
Okay, well, we're left with 12.50y less than or equal to, I'm going to lead with the negative 7.5, so it looks like mx plus 100. They're not like terms. I can't believe I have to say that. Now do what? Divide everything by 12.50 divided by 12.50. So we get y less than or equal to, hey, listen, could I just keep this as, like, to graph it? Now you guys got negative 0.6, right?
Yeah.
Which now, Tegan reminded us that that is negative 6 over 10, rise over run, right? Could you also not just leave it as down 7.5 and right 12.5? You can count half things, can't you? That's valid as well, right? You could, yeah. Right? But anyway, let's use the negative 0.6x
Done.
plus what?
8.
8. Right? So I could either do this as my slope, or remember, I can write it like this. Negative 6/10 x plus 8. Agree with me on that? Okay. So go ahead and plot that thing. Where do you put your first point?
8.
On the y-axis. And where do you proceed from there?
Down 6 over right.
Right 10. Looks reasonable from here. It's about the right shape-ish. So let me put in a, you guys are all doing this. Don't wait for me. You know where number 8 is, right? Do I have to tell you how to count to 8?
I'm on fire today.
Oh, you're in the wrong room.
So I was about for half the lesson of this lesson.
And so you can't count to 8? Is that what you're saying?
What? No, I
Oh,
I'm on fire because I
2,
just
3,
learned how to
4,
do this.
5, 6, 7, 8. So here's my 8. And you might as well label that, right? If you're going to use that, might as well put an 8 there. And we're going to go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Straight edge. Are we going to have arrows on this, kids? Why not?
It's either a or not.
Right, this is a real world situation, right? Are we going to end up going below here and have negative evening tickets?
No.
Or going this way and have negative matinee tickets? Well, then you just have 0. So let's get our in there.
Oh yeah, got right.
Oh, like that?
Yeah.
Solid line, yeah?
Uh-huh.
Which way are we shading? Above it or
Below.
below it? Why below it?
Because it's less than.
Because it's less than or equal to.
And also the top.
The top will take more time to shade it.
So we're going to have to rewrite all the math books now. We have a new reason for shading in a particular direction. Jesus. Oh. Oh my God. And hey, do this, put that big fat S in there.
As
Okay.
so much as the guy.
You get the idea? So, you guys understand how to write this inequality to begin with, right? Every matinee ticket is $7.50. X is all of them. Every evening ticket is $12.50. Y is all of them that you buy. Okay? So you understand, right? Everything on this graph now, right? And by the way, where does this hit down here? What number? It's 13, right? Hey, so every combination in here is a possible purchase of a certain number of matinee and evening tickets, right? Where do we max it out at? Where will we find points where we max out our $100? In other words, where the two of our tickets together add up to 100. What points will tell me that? What points can I pick on this graph? Think of the, up here. On that graph will be combinations of matinee and evening tickets that max out our $100 that we have. Point down here, buy one of each. If I buy one of each, if I buy one matinee ticket and one evening ticket, have I maxed my $100?
No.
No.
Oh, so.
Where do I find points that will maximize the $100 I have? Points, I said plural. Where? No, I don't want, don't give me numbers. Tell me where on the graph I will max out my $100.
Where your line ends on each side.
Above the line.
Above the line, then it's more than $100.
No, I'm like whatever point on the
Oh,
line.
where it intersects the x-axis.
No, whatever point is on the line.
Let's try one matinee ticket, so over one,
Yeah.
and 7 evening tickets. Have I maxed out my $100?
No.
Not quite.
You can go on the line.
Oh, so
Oh,
where will I find points that will use my entire $100?
on the line.
Points on the line.
Mm-hmm.
Because those points are, look,
We are so.
the points that are on the line are where the matinee and evening tickets actually equal $100.
So what it would be like 5 to 5? That would be on.
I guess, yeah, 5, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Sure, it's hard to, like, is it a little few cents above? So you have to plug it in, okay? So now, thinking of it that way, answer this follow-up question real quick.
I already did that. Wait. I didn't. Wait.
What's the maximum number of matinee tickets for the $100 that you could buy?
But we already did that up there.
What's the maximum number of matinee tickets possible to purchase?
13.
Why 13?
On the line.
Because that's the matinee tickets.
So what does 13 matinee tickets cost you? How much are they?
12.50.
750.
213 times 7.5.
Oh, it's 750. I thought there were 12. Oh, 97.5.
Which means you can't buy another ticket of any kind if it's 97.50, right?
Yeah.
Okay, so she can buy 13 matinee tickets if what?
If she only buys.
If she buys 0 evening tickets, right? Does that make sense?
I spelled tickets wrong. I said tickets.
If she buys 0 evening tickets. Right, because what are the coordinates of this point out here? 13, comma, 0, right? That's the max matinee tickets you can get.
Keep spelling tickets wrong.